Okay. Okay.
Um, but I have a lecture on a Thursday morning, but it's a problem class which the students have to sign up for if they need help. Um, and not a lot of students arrived on Thursday, but the problem is that's what's scheduled on a Thursday at 8. So that's the reason why I couldn't make Thursday morning's meeting.
Yeah. All right. But in the future, probably it's just a one time, right? The
No,
last week.
well, so that's I mean, it's going to be a problem until it's not going to be a problem next week, for other reasons. But the week after that, it might be a problem. But it's only in the first semester. It's only going to be up till I think the end of May or something like that. That
Oh,
there's
I see. Okay. Okay. All right. Okay.
so the option is either to have our meeting half an hour earlier, having it at
Okay.
7:30. I don't. That might be the easiest solution.
Okay.
Um, no, that might actually be the easiest solution.
Okay.
Um,
And or changing to Friday, but that is that preferable or not?
Changing to Friday is also an option. That is
Okay.
also an
But
option for
maybe
me.
easy.
Yeah,
I think
yeah.
half an hour earlier may be easier, right? That's the lowest paying adjustment.
Yeah.
Okay. Okay. All right. So right now it's Tuesday, right? All right. I think let's do that then. All right. Okay. Let's do that for the time being. Yeah. All right.
Cool.
So is Victory online now?
Hi, Shunyan. Hello,
Hi.
sir.
Hi.
Yes.
Hi. How have you been?
How are you? I'm
All
good.
right.
How are
Good.
you?
Good. Good. All right.
All right. Let
So
me
yeah. So let's get
start
started.
it.
Yeah.
Yeah.
All right.
Cool.
Yeah. All right. So go ahead.
Share
Yeah.
screen.
You can share your screen.
Oh, status. I did register, Professor Hammond. Finally yesterday.
Awesome.
Thanks again for that. Trying to see my screen one. Yes. All right. Can you see this?
Yes.
Okay. So maybe I should just start with the sequence. I try to break it down and show the variables here, but the idea was there's a pub and sub sequence that occurs. All right, sub request. Again, this is sort of variable. It sort of changes a bit in the code, but it's an idea. If it's a sub request, create this ID, for example, and create the channel you're requesting to subscribe to, the data table, and send that data to Matcha. And if not, basically, if it's a pub request, create the ID with the message. I mean, create data table with the ID message, send that information to Matcha, wait for response, print response, and so if you notice, there's a dotted line here. The idea is because it's gonna be on. This happens on one node, sub and pub, and the this does not necessarily happen on the same node. It can, but it's optional. That's why the dotted line is there. But assuming it doesn't happen on the same node, this is what happens. It creates the database.
Hello.
This is
Your
hello.
Herman. Can you hear Victory?
Can you hear me?
Yes.
Oh yeah. Yeah. All right. All
Yes.
right.
I
I
can hear
wasn't
him.
hearing.
Yeah.
All right. All right.
Oh,
Go
okay.
ahead. Go ahead.
Okay. So basically, we check in for requests. Is it a sub request? Now, again, this sort of changes in terms of reality when you sort of start writing the code. I think I will show you. Then sub request get ID. So this is now if the matcher receives a sub request, get the ID and channel, which is that node which was sent. This and add to the database. There's a sublist database and wait for message pub request send sorry if it's a sub pub request, and again I should probably take this out because technically this is what triggers the pub request. So it checks the database, it compares the database table with the so there's a pub what do you call it table, and it checks it to see if it exists. If it exists, get the message, right? And basically get the message means, send the message from that node to the subscriber. And if not, send requests to other matches. If the matcher contains the channel that it's requesting for, get the equivalent message as well. Or if not, just send error message and end. And yeah, so that's like the basic general overview now. So when I go into the code, so what I did was I didn't necessarily start from here. I started from the end. So for example, this was the sub request. The idea is it's triggered by true or false. So the assumption is a subscriber has asked to has subscribed for has made a subscribe request, right? So the idea is okay. So this is just to sort of track what's going on in terms of like a log file. So print that, then sub data. So now this was a slight addition. I needed a way to flag, you know, what a sub request was and what a publish request was, because they both go to the same matcher. Um, Again, there's probably a better way to do this, but for now, this was very effective. So the idea is, if it's a substat, just add one, the number one in as a flag into the data list. So it basically checks. So if this is true, send this information to matcher. Now that's S data now. S S data technically is data now, not necessarily S or P data, but for the sake of variables, because I played around with the code a lot. So now if you look at this is a function that basically sends to matcher. So the idea now is check S data array and check the initial what do you call it, the initial value. So it checks the first value. I mean, it checks, so there is a substat, there's popstat. So if it's substat, flag it as sub, which is sub request. And if it's a pubstat, which is publish, it's maybe there's a trigger for you to publish information, then publish that information. Create a flag, right? Um, Create the ID, create the channel, check, then the message. Basically structure this data into a small array and send that information also to the matcher. Now, if you notice now, there's like two sections here. What happens when the sub data, the subscription is triggered, when the publish is triggered, right? And that's where, that's where this sort of comes in. So if this sub request comes in and then pub request, what happens, right? And if that is the case, then first print, just again to track what's going on. Then I used the library called I think Tiny SQL or something like that. Just the basic. I might have to upgrade it because I'm sort of finding challenges extracting data. I can find data, but I can't sort of isolate one, and I'll show you in a bit. But it's simple, print, sub, initialize. So the idea is just insert the table, create the data table. So what I did was I created two data structures, and I'll show you very shortly. There's a table one, and if you check here, table one is the sub list. So there's a table with the subscription list or request list, and then there's the table two with the publish list, or should I say publisher list. Now that's where, so table one, once this has happened, basically insert the ID. What's the ID? So it's like a JSON file, and then it gets the data. So that's the one is the ID, and two is the channel, right? And then print sub added to DB. I'll just run it now. So the idea behind this, maybe I should go to this first. Something similar as well here. If S data 0, if the initial variable is flagged as publish request, print pub activated or pub request activated, insert these variables, the ID, the channel, and the data. right? And then print, pub request sent. Yeah, so now this is where things sort of got a bit tricky. So the idea now is now comparing the table, which is for some reason I think I just do stuff at my computer this morning. But queries, the idea is I'm checking the table, but I'm checking table 2, right, for this query, and the query is the channel in the pub list, which is table 2, is that channel the same as what channel this thing is requesting, which is from table 1, S data table 1. If true, right, then sort of print it out, which is to print and then extract. And if you notice here, the idea is when I want to extract, the idea is print out everything, loop through each value, and then print just the name, or just print the message alone. But I don't think that part works. So I'm just gonna run this. If you notice here, the table is set up to create a file called db.json. So I have it open here. So I'm not going to delete this because I'm using it as a random, because it sort of appends to it. It doesn't necessarily replace it. So I'm just going to run this. And when I run this, you would see the sort of sequence. There's a sub request, initialized, added to DB, basically showing up, tracking what's going on. And this is where this is the part that talks about what you call it, print QR. So this is the query. The query is saying, where's channel? Okay, the channel in the loop, is it equal to, what the request is? So in theory, we have a node that's 2, right? So if I open this notepad, it's probably gonna ask me to reload. Yeah, I'm gonna select all. I just wanna make it cleaner. So tool for that. So if you notice here, okay, sorry. So there's a sub list. The reason why it's a lot is because I've run it so many times. So it sort of just keeps adding on. But the idea is simple. You have the sub list, which has, again, ID1. Because of the library I'm using, this is a bit, sorry, this is wrong. There's not that, this maybe ID2. It has an ID, it has a channel. So it has one, or port, IP port, depending on what it is. It has the channel we're subscribed to. It could be 0, it could be 1, it could be an alphabet. In our case, at the moment, the focus has changed to like numbers. And then the same thing, if I go down to, published. So there's a publish table as well, which is ID. It has the channel, it has the message. And it's also, so the comparison sort of happens, it checks, what this two, and that's why it gave that list at the here. Yeah. So what I'm trying to do now is I'm trying to loop through this and simply just capture the, sorry, where are you notepad? I'm trying to loop through all of this list and capture just the message that comes with 2. So for every channel, for every node with channel 2, get all their messages. So I'm gonna play around with the data as well, just to be sure that it's working. But in the meantime, I think that I do have that. Any comments?
All right. Okay. Herman, any feedback so far?
Yeah, so I mean, I'm glad to see you have I think it was a good idea to draw that flow diagram and then basically implement that. I mean, using something like the Tiny database or SQLite or something like that. I mean, that's fine
Yeah.
if you do such a what do you call it, prototype implementation as you've done here. The comment that I have is more to do with the way you approach the debugging of your system. So I would suggest I don't know if you've if you've heard about something called test-driven development. or you're using Python. So it's basically, you've got this concept that if you want to write a piece of software or write a piece of functionality, then what you do is you basically think of how do you test if you know that the functionality that you've implemented is correct. So for instance, you have a publication, right? So you're sending,
Yeah.
oh, sorry, you have a subscription. So your matcher is receiving a subscription. How do you know that the matcher has processed the subscription correctly? And then what test-driven development basically says is you write the test. So you say you define what the initial condition of your database is, and you define what the condition of your database should be, or the state of your database should be after you've correctly processed the subscription request. And then you write a test, which basically sets up that initial condition, basically creates a message, passes it to your matcher, and then queries the matcher's database somehow to check if the state of the database is what you expect it to be. And the advantage of doing that is that you have an automated test. So it means that whenever you can just press a button and run all your tests, and if all your tests pass, then you know your system is, well, it's working as well as if you've written your tests. But it also forces you to think about, how do you know your system is doing what it's supposed to be doing and doing it correctly? So I think this is great. I have found in the past that using something like test-driven development makes it easier and more, more sustainable when developing software.
Okay. I'll definitely look into that.
Okay.
I did do some tests. It's just, I think it's just manual and not
Okay.
automated.
All right. So thanks. So Herman's main feedback is to make it test driven, right? To make the development more test driven with test cases.
Yes, yeah, because I think
Okay.
we also could then help look at the test cases and say, yes, that test you have for processing a subscription message, that looks correct. That is what the database should look before and after you've processed the message.
Okay.
Okay. All right. So all right. So I guess for my feedback here, the first thing, I think it's very good. You have the flow chart and also implement that, and now you have working code, right? So I think this is good. Okay, this is an important milestone. And also I can see that you are actually creating test cases already, right? Because you are sending, right? You are sending publication and subscription requests to the matcher, right? And somehow do that in some kind of sequence. Okay, so I guess my feedback is more on the design, okay, on the how the software system potentially should run. Again, using database, tiny database to store it, I think that's fine. There is something, however, I think which I like to see in the next version, okay, in the next iteration of this, which is to actually perform the actual PubSub mechanism. Okay.
Okay.
I think I mentioned this last time, because I still consider that as sort of the main path. There's regardless of logic, how big the system is, there's always a main path, and try to remember that. Okay. So I think I haven't seen the main path being done yet. Is that correct?
Yeah. So
right. Okay.
It's sort of something I was going to ask. So for example, the matcher, it looks like I would probably have to create this in a new file. This whole flow for the matcher. When I say new file, like a different file to sort of illustrate it's a different device or node, and then sort of link it somehow to this.
That's one way to do it. Okay. If you recall, I was recommending to keep your code into different, I guess, components, okay, or
Okay.
different
Yes,
parts.
I remember
Like one, there may be one that may be called the behavior model.
that.
Okay.
Okay.
Like for example, like right now you have, I think you have a code where you actually, you know, if the pub stat is true, then you prepare like the line 111, right? You prepare a request, you send to matcher, right? This is a behavior, you see?
Okay.
And what you want to do is not just to manually write one or two behaviors. Potentially what you want is to have a loop, right? That
Yeah.
loops through a bunch of nodes and then perform one behavior, like one
Okay.
description or one publication. It can be random or it can be like predetermined, you know, however you
Okay.
like this to be done. But essentially, you have to have a place that generates behavior, okay?
Okay.
And potentially, you know, the behavior has to be repeatable,
Okay.
okay? Remember, this goes back to when I was talking about, right? So you want to have repeatable, you know, reproducible simulation so that you can debug, right? This actually relates to what Herman talks about the test case. Okay, you can think of
Okay.
this as also a kind of a test case. When you are done this in a repeatable manner, in fact, that is your test cases. You see?
Yeah.
Okay, so even if you haven't done the actual implementation of any kind of pub sub, you can actually write the behavior model. Okay, and then also,
Okay.
you know, maybe write some verifier. Okay,
Okay.
that kind of
Okay.
checks whether the results is what you are expecting. So I suppose this will relate to more like the what's called test-driven development, TDD. Okay, which is before you actually write any kind of logic code, you write the test cases first.
Okay.
Does that make sense?
Yeah. Yeah.
Okay, so I mean that's behavior model is the first part, and then you have the core logic, okay, which is I think mostly the matchers logic. Okay, so that is the pub sub layer, right? And
Okay. Yeah.
and the pub sub layer is based on or it has access to the overlay layer. Okay, that is something, you know, when we're doing the spatial pub sub, we could have. But right now, if you're just working on channel-based pub sub, for example, I don't think that's necessary. Okay, okay. And at the bottom, you have the network layer.
Yeah.
Okay, and network simply does, you know, network communication delivery. So it might take some time, you know, to sort of figure out how you can, you know, build these different layers and interface. But this will be, I think, a cleaner approach in terms of you can have independent components that do not rely on each other. Okay, note the independence is an important decouple. That's a key word, meaning that, for example, when you are doing simulation, you put in a simulation network layer for the message transmission. But when you are moving to a physical actual environment to test, you simply replace the network layer with, you know, like rail TCP/IP transmission or UDP transmission, you see?
Okay.
And you don't have to change any of your logic, you see?
I see what you mean.
Okay, so that makes sense?
Yeah.
So I think this is the part I mentioned about the separation, but also note that in the beginning, you don't necessarily have to do or maybe have the experience to do clean separation, but that's fine. Okay. So the first thing actually I would like to see is I guess you can either write the behavior model first. Okay, I think that's what also in line with what Herman is saying. And the second thing maybe to write is the matcher logic. Okay, the matcher logic actually does the, you know, the pub sub matching.
Okay.
Okay, so I think I guess that's my feedback. And another feedback regarding how you are using the database now. Okay, is
Okay.
that right now you are simply recording out the, for example, the subscription requests into like a giant list, right? Like a
Yeah.
log. Okay. In
More a bit, yeah.
reality, I think in such system usually it's not a log, but rather it's always just the latest version. Okay, so for example, if
Okay.
node one subscribe to the first channel, like the main channel, for example, or channel
Yeah.
number one, and then it does it again, and then does it again, right? You don't have
Okay.
3 records in your subscription list, or your subscription.
Okay.
You only have 1 record. You see,
Mhm.
you only have 1
Okay.
record saying that okay, node one is subscribed to, like, let's say channel one. Okay, unless you have another record that says node one wants to subscribe to channel two.
Mm.
You see,
Okay.
does that make
Yeah.
sense?
Yeah.
Okay, so some kind of mapping structure, not instead of an array structure, might be needed in place. Where you can use the node name or node ID as the key. So it's more like a key value kind of mapping.
Mm.
I'm sure in Python there are data structure like that.
Yeah, it does
Okay.
have
Yeah,
this
yeah.
insert
So
function.
mapping is what you want to use instead of array.
Okay.
Okay, for basically, and I think for database, I don't feel it's necessary to introduce a database at this point because
Okay.
I mean, essentially, unless you're using for logging purpose, okay, for logging and verification purpose, because
Okay.
this is another, I think, important concept, is that in simulator like this, you have to distinguish between transient data, and also persistent data or permanent data. Okay.
Okay.
What I mean is something like this. Okay, so usually the permanent data relates to states. Like in a game, for example, like the character's name, right? Its health points, its mana points. These are persistent states
Yeah.
that should remain the same regardless of, which game loop you are currently running, for example. Okay. So those are the things you will want to keep in a database. Those are persistent data.
Okay.
Okay. However,
Yeah.
requests such as publication requests, subscription requests, move requests, action requests, chats, okay, they are typically just transient data. This is called transient data. Okay, or in the in the simulator world, in the military simulator world, they call this interaction data. Okay.
Okay.
So do you see the difference between, and do you see why they are called transient? Okay. Different example. For example, like movement. Okay, movement is transient because once you indicate I want to move to this place, right? Then what happens is it's a message, but then it affects some states to change. That's the position is changed. But then you don't need to keep this transient message anymore. Once the effect is there, it's gone. I mean, the message can be gone. You don't have to keep it. Okay. So in your case, publication subscription requests, they only serve the purpose to notify, right?
That's it.
To notify the matcher. But once matcher, let's say, records that into maybe like a subscription table, right? Which could have a different data structure, then the message can be discarded. Does that make sense?
Yeah, it does.
Okay.
It does.
Like right now, I think what you're doing is you're recording all the requests into a log. You see? Okay. And this is not to say log doesn't have its value, but for our purpose now, which is to get a minimum, workable program that can perform channel-based PubSub, for example, right? That is not necessary.
Okay.
You see?
Okay.
All right. Does it make sense?
Yeah, it does.
Okay. All right. Okay.
So Shunyun,
Yep.
just a question from my side. When you
Okay,
refer
sure.
to the behavior model,
Right.
do you mean that's the roles of the publisher, subscriber, or matcher, or
Well, it's you can think of very simply, like for example, how many publishers, how many subscribers you want to run in this entity. I mean, in
okay,
this simulation, right?
okay,
And like, I mean, like in a purely pub/sub scenario, what you can do is you can like randomly generate some events. You know, like
Mm,
I will do a subscription at the third second, right? I will do another
Okay.
publication at the fifth second, right?
Okay.
And I sort of pre-generate this up to, let's say, 1,000 seconds.
mm.
You say
So it's the behavior of the simulation you're referring
exactly
to,
of
not the
the
behavior.
entities
Yes,
within the
yes, I'm
simulator.
with you now. Okay, cool.
Okay.
Okay.
Cool.
And this is important because you want to be able to reproduce the whole simulation sequence so
Yes.
that you
Okay.
can debug the logic at this stage. Okay.
Okay.
So this
So
is why I see there are some major components. I mean, this is what
Mm.
happens in the vast library. Okay.
Mm. Mm.
Which is there is a behavior model, there is a logic layer, there is
Mm.
a communication layer, okay, which is
Mm.
the overlay, the peer-to-peer overlay, the one part, and then there's a network layer, a network
Mm.
that is responsible for you know, just end-to-end communication.
Mm.
Okay.
And in
Okay.
the end, when you deploy, when someone actually deploys the system, then I mean they basically use the logic and all the other layers. The behavior model is, but you don't need a behavior model. then
Exactly, exactly, because
it's-
behavior model has been replaced by actual human
Right.
behavior, right? For
Precisely,
example,
yeah.
right? And then you also replace the network layer to not be a
With a real
simulated
network.
network, yeah, but a
Yeah.
real network. But you
Yeah.
do keep
Okay.
the middle two parts, which is the
Yes.
overlay part, the overlay peer-to-peer part, and also
And the
the
logic.
pub/sub logic, the pub/sub logic.
Yes,
Yeah.
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 Cool.
Okay.
Okay, does
Okay.
that make sense?
I see what you mean. Yeah, I do.
Okay.
I do. It makes
Okay,
sense.
okay, good, good. All right. So I think for next, I think probably, I think Carmen and I, we do have agreement here. Maybe you can write the behavior model first, you know,
Okay.
because
Mm.
it actually serves as a test case. Also,
Yeah.
once that part is done, you know what your logic module should support. You see,
Mm.
Okay.
because even before you have written any line of code for the logic, if the behavior model has been done and you know how to verify, then you know you have to write certain logic to sort of produce the expected results,
Mm.
right? And that will make this test driven, and also you can make it automated, which is another
Yes,
you know
yeah.
good aspect.
So the
Okay.
behavior model, Victory would do something like start up 10 nodes. One of them is a
Yeah.
matcher. Two of them are subscribers,
Exactly.
or something like that. And then you would say, okay, 10 seconds, then this one will send this message and it must reach that one's or these nodes.
Okay.
And then you can basically have a verification part, which basically says, did all these nodes receive that message as it should have? Something like that.
Okay.
Yeah. Yes. Exactly. Essentially, you want to
Okay.
think in terms of what's called time steps. Okay.
Yes.
Okay.
You know, time steps are just logical time units. It can be 1 second per time step. It can be like, you know, like 1/10 of a second per time step. Okay, it doesn't
Yeah.
matter, but you want to generate your behavior according to different time steps.
Okay.
Okay,
Okay.
so the behavior model might work something like you put like just like 100 as a parameter, then it will generate 100, you know, behaviors for the next 100 time steps, for example.
Mm.
Okay.
Okay.
All right.
I see what you
Does that
mean.
make sense? Okay.
It's basically
okay.
like a mini simulation.
Exactly.
Yes, that's exactly
true.
what it is.
Yes, exactly. Yes.
Okay.
Okay. All right. So if that's good, then maybe that's what we'll see. Okay, next. And if you still have time, you know, you can work on the logic of the matcher.
Yes.
Okay. So basically, those are the two parts, you know, we like to see, I think, next time. All right.
All right.
Yeah.
Yeah.
7:30 on Thursday.
Yes. And we changed half
7:30.
an hour earlier. Okay?
Yeah.
7:30
Yeah.
on Thursday.
Okay. So from now on, right? I mean,
Okay.
so on Tuesday
Cool.
as well.
Okay.
Is that right?
No, we only need to change Thursday. Tuesday 8 o'clock is fine with me.
Thursday. Okay. All right.
If it's easier for you, we can change it to 7:30 on both days.
It will be easier for me because that's oh, sorry. I think yes, it will be easier for me as well. Okay.
Okay, cool. So
Because
7:30
that's,
both days.
Right.
Okay.
Yeah, okay.
Cool.
All
Okay,
right.
let's do
Tuesday and
that.
Thursday. All right. Okay.
Yes.
So
Thanks,
talk
everyone.
to you then. Yeah. All right.
Okay.
Yeah, take
Thanks,
care.
Julian.
Yeah. All right. Okay.
Thank you,
Thanks.
sir.
Bye bye.
Thank you, Shinyan.
Yeah. Bye bye.
Bye.